Another idea we're going to be doing is taking the graph of a function and drawing the graph of its derivative. Now the derivative is the slope of the tangent line. The slope of the tangent line is derivative. There's certain notations that we're going to be using to indicate that something's a derivative. One common one is f prime of x. So if f of x is the function, f prime of x, the little single tick mark there, would be its derivative. Another one would be dy dx. So if I have an equation y equals something, the derivative of that would be dy dx, which means the derivative of y with respect to x. That's how you would read it. Or you might have a more fancier notation, the derivative of the function of x with respect to x, something like that. All those notations. And there's a bunch of other different ways you could kind of reassemble things and all mean the derivative. The primary way you're going to see us use is the prime here. Occasionally you'll see this. Very rarely will you see this in this course. So now, as I look here, here's the function of x. I want to draw the derivative, the graph of the derivative. So what I'm going to look for first is all the places where I have a horizontal tangent line. The slope of a horizontal line is 0. So I would know that the value of the derivative there is 0. So let's take a look right here. This peak would have a horizontal tangent line. That is, and let me draw a few tick marks in here so I have some values to look at. There we go. Okay, this looks to be at x is -2. So at x is -2 over here, I'm going to write that this graph, that this derivative has a value of 0. Okay, so let me say that again. The tangent line here is horizontal, slope of 0. So the value of the derivative at -2 is 0. Okay, you see -2, 0. -2 here is horizontal slope. So here the point is at 0, meaning no slope. Okay, another place where that happens looks to be in this case around 2. So around 2, the slope of the tangent line is 0 right down here. Okay, and so it also intersects there. So those are some points on my derivative, my graph of the derivative. Now if I look at all the points coming up to this point, these look to be positive slope. The graph is going up, the tangent lines are pointing up, that's a positive slope. And it's actually getting smaller, meaning as it comes closer to this, my value of the slope of the tangent line is getting smaller. It's getting closer to 0. So it's positive value, positive slope. Well, are positives up here or positives down there? Well, positives up here. So I'm going to be coming from here down to there. From there down to there. My slope values are all positive here. Okay, again, this function is, the value of this function is the slope of this function. So the value here is positive right over here. The slope here is positive right over here. Okay, this next section from here to here, that's a negative slope. So I'm going to have negative values here, meaning below the the x-axis here. So I'm going to have negative values from here to here, because you can see from that point to that point, from this 0 slope to that 0 slope, I have a negative slope. So that would indicate a negative slope below the x-axis. Now after this point, I have more positive slope, and it continues on. And actually, what I have here is something that resembles a parabola. In fact, indeed it is. And we'll be, if we were to write this equation out and find its exact derivative, we would get an equation that looks something like this. Now, again, these are approximate drawings, so they don't have to be perfect, but they should get the kind of shape. I mean, this is not the greatest graph in the world. The points aren't all in the exact spot, but the idea of the shape is correct. The derivative, the value of the slope here, is representative of this graph here. Okay, so once again, I know this is going to be a confusing topic for a little while. We're going to be pushing into the idea of the derivative, and it all boils down to slope. What's the slope here? And I'm going to translate that to a value. Again, I'm not translating that to a slope over here. See how this is a negative slope? but the value of the function is positive, the slope over here is positive. So slope positive, value positive. That's the correlation. Slope negative, value negative, and lastly, slope positive, value positive over here. And again, derivative, slope of the tangent line. Okay, we got a lot of work to do on Monday, and better come ready.